ASCII characters. So back in old days when the computers were built, you know, there was no Korean characters, just they used pretty much what you see on your keyboard. Okay, so you have letters on your keyboard, and of course you can switch to Korean characters, but if you use a US character keyboard, you will see like the American, there was A to Z, and then you have numbers, and then you have some special characters, and then you have like a tabs, enter, caps, shift, control key, alt, escape, and that sort of characters. Anyway, this shows the hexadecimal number representation, but let's to make it a little bit easier, you can go to ASCII.com. That shows like these different form. So hexadecimal number, decimal number, octal number. It doesn't show binary number, but if you want it to, you can stick a binary number as well. So these are all the characters that come. Okay, the original ASCII, there was 127 characters, and then the extended key that used 255. Let me see, 250. Yeah, I think 127 because they use 7 digits. Anyway, that's not as significant. So let's say you use everybody has a space. So I remember space is 32, decimal number 32. So you get the decimal number and the hex. Actually, you know, we did that thing, right? So we go 32 divide by, to go from the hex to decimal, we go to divide by 16 process. So you go 2, right? So you go 2, 0. So that's the the decimal to hex number. Okay, right? Remainder. So 20 hex. Okay, so anyway, so that gives you the ASCII character. So these are all the ASCII characters. It uses 7-bit. The extended ASCII has a lot more characters than 7-bit. This is original, which is 7. 1, 2, 3, 4, 5, 6, 7. Okay, which you multiply, you know, a bunch of times and figure out how many combinations. That should be 127 combinations. 128 combinations, sorry. But this number should be 127 because that's the last number. The first number is 0, so that will give you 128 combinations. This will be 127. The last number will be 127. So anyway, something about the ASCII character, and that's a popular format still used today. You will see some data characters in that format. Okay, going back to this slide, but this one only shows the hexadecimal number. So space 20, so we know the hexadecimal number 20. Where's the space here? So here. So you read from this one first, and then you go here. So 20. Okay. This, you can tell me which ones. Hexadecimal representation. So if I ask you on the exam, give me a M, and I give you this table. Okay, well, 4D, simple, well, no problem. And if you have to give me a decimal number and you didn't have a table, but you have to work out a little bit, but not a problem, right? Okay. Okay, we kind of we don't have much time, so I put this posting IP address. We'll talk about it on Friday. Okay, and then the purpose is I want to share this, answer this question, this second question. All right, so let's kind of briefly, as I told you, the last time there's a version 4 and version 6 of the IP address. Okay, the version 4 had a 32-bit system. That means what? 32 bits. And version 6 that used how many bits? Like a 128 bits, something like that. So let's actually, let me give you an example. That's a version 6, looks like this. Version 4 looks like this. Okay. So the version 4 uses 32-bit, and so you have a dot. So 8-bit, 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 8-bit system. All right. Now, when you use the 8-bit system, last number, the very last number is all ones. 8-bit system. The first number is what? The zeros. All zeros. So when you work out this problem in binary number to decimal number, we went through the process, right? 2 times 1 plus 2 to the 1 blah 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 times 1 blah 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 blah. The very last number is 2 to the 7 because you start with the 0 times 1. So you work out all these problems, and then if you add all these numbers, the last number you should get decimal number 255. Okay, and then the first number was 0, right? So you actually have, combination wise, you have 256 numbers. 256 numbers, 256 numbers, 256 number. But the last number is 255 in decimal, binary, all ones. Alright, that's what I meant by, like, this student asked me, okay, 255 plus 2 plus 1 became 256. Combination wise, 256 combinations. That's different. The last number, very last number, is 255. And then you have the first number is what? All the zeros. Because 0 is a number too. 0, 0. You can, sometimes IP address you can have a 0. So 0 plus 255, so you have 256 combinations. Okay. So going back to this IP address, this is the version 4. So you're playing, basically you're playing with this 32-bit system, and this was okay until just a few years ago. But we have like an Internet of Things, IoT, which basically the concept is that every device on the internet will take IP address. Now think about the IP address. Sometimes you don't realize the IP address, but basically everything on the internet needs an IP address. It's kind of like your address. If you don't have an address, they don't know what to send you, right? Where to send you the things. So it's like an address, unique address. Everybody has a unique address, so we can send the data to proper place. So that's how the internet works with the IP address. So that concept of IP address is very important. We'll get to discuss some things on this here on Friday, like classes and different types of IP address, and version 6, which is how many bits? But if you look at here, you see here lots of zeros. You can count these if you want to, but without counting here lots of zeros. Here hexadecimal number, right? So each full hexadecimal number, right? So full hexadecimal number times each hexadecimal number takes how many bits? 4 bits for each hexadecimal number. So 4 times 4, that's 16. Each here, that's 16 binary number. So how many times have we got? 1, 2, 3, 4, 5, 6, 7, 8. So 16 times 8, so that will be 128. So you see bottom here, there's 128 bits, lots of zeros and ones. So that's a version 6 address. So we use both version 4 and version 6. In the lab, we have what we call static IP address. That's dedicated IP address in the room 346. At home, when you use typically at home, we use what we call dynamic IP address. Static IP address does not change. Dynamic IP address, when you turn off your what we call router, which is a 공유기, the address will change to or pick up a new address. The address will change. That's the difference. Okay, so take a look at this and we'll discuss on Friday, and you can send me questions. Okay, talk to you later and have a nice day.